In our own laboratory here at Rice University, we have a unique non-destructive pulse magnet system ideally suited for optical experiments in high magnetic fields. The system, called the Rice Advanced Magnet with Broadband Optics, or RAMBO, is a tabletop pulse magnet in an optical cryostat. The system uses a dual cryostat structure, one cryostat keeping the magnet at 77 Kelvin and the other keeping the sample temperature at any value between room temperature and 10 Kelvin. RAMBO can produce a 30 Tesla pulsed field with a rise time of a few milliseconds and a wait time of only 5 minutes between two shots. Because of its very small footprint and excellent optical access through a large window, it can be easily incorporated into a standard optical spectroscopy setup. It is particularly suitable for performing ultrafast optical spectroscopy or nano-optical spectroscopy experiments on materials under extreme conditions. Let us give you a quick tour of the RAMBO lab.
Here we have a 30 Tesla pulse magnet. It's a mini coil pulse magnet. This is an example of roughly the size of the coil in this system. We cool it down to liquid nitrogen temperatures, so we basically have a cryostat here full of liquid nitrogen. And then we deliver up to 5,000 amps through the coil with a capacitor bank here. So we charge up the capacitor bank to almost 2,000 volts, and then we trigger the circuit so that at peak 5,000 amps flows through the coil, and it happens in about 10 milliseconds. And the current goes through and generates a magnetic field up to 30 Tesla for this magnet system. So we use this for ultrafast spectroscopy, in particular terahertz time domain spectroscopy right now. So it's in a spectroscopic setup here. So we basically can put windows on either side of the system to couple the high magnetic field with the ultrafast optics and the ultrafast pulses. So we synchronize the magnet system, or trigger it off of a laser system, so that a pulse from the laser comes in and interacts with the sample at the same time that the sample is experiencing the peak of the magnetic field. So we can do measurements up to 30 Tesla and down to about 10 Kelvin with this system, and it's unique in terms of having great optical access, small size, and coupled, in this case, with terahertz radiation.